want to carry on with some more questions from section 4.1. I want to do question 6. It's a lovely question. A car is worth £16,000 and it loses a quarter of its value every year. In other words, it goes down by 25%. That's a quarter, isn't it? How much will the car be worth after 4 years? Well, if I've gone down by 25%, I retain 75% of my value. So I'm going to take my 16,000 multiplied by 0.75, and I'm going to do this for 4 years. So it's power of 4. Grabbing a calculator. 16,000 multiplied by 0.75 raised to the power of 4. So jumping straight in, my car, this is horrific, is worth £5,065 and £62, so it's even less, and 50p. How's that? There you go. Don't ever buy a new car. It goes down drastically really quickly. So there you go. After 4 years, you're smashing £16,000 sports car is now worth about a quarter of its value. There, roughly speaking, third of its value, should we say? Anyway, that's the answer. That's that one. Sketch a graph. I'm not going to sketch no graphs. Going out. 5 years, 6 years, 7 years. I'm not going to do that. You can do that in class. Number 7. A young manager has a job with a starting salary of 19,000 squids, and it's increasing by 2.4% each year. So she's going to get a wage rise. Yes, she is. What is her salary after 1 year? Alright, let's do this after 1 year. It's 19,000 multiplied by 1.024. Recall, 2.4% is 0.024. So let's see what her new wage is going to be after a year. So 19,000 starters multiplied by 1.024. She can expect to get £19,456 after 1 year. So in her second year of work, that's what she can get in her second year. After 2 years, what should she get? Okay, 2 years is not a problem. 19,000 multiplied by 1.024 squared, because I'm going 1.024 for the first year, multiplied by 1.024 to give her a wage for the second year. In other words, power of 2. So here we go. 19,000 multiplied by 1.024 raised to the power of 2. Bam. 0. Of course it's not. 19,000 times 1.024 powered up to 2 equals. There you go. She will expect to earn at the beginning of her second year 19922 and 94p. There you go. About 1,000 quid or so, 900 quid. After 10 years, oh grief, alright then. So this is leading somewhere in a minute. I mean, honestly, how can you keep on getting a wage rise and a wage rise and a wage rise? So do this for 10 years. So 19,000, 1, 2, 3, and here she is 10 years afterwards, if she's still there, multiplied by 1.024, raised to the power of 10 years. So she thinks she's going to earn £24,085 and some pennies. Well, okay, fine. And the punchline is, your answer to part A3 may not be very realistic, and why? Well, this is the third part. So I suppose we could say you cannot always expect the same wage rise every year. So I'm going to write it down. Alright, you may not expect the same wage rise every year. There may be a wage freeze. In other words, we've had enough of putting your wages up all the time for not doing anything more in your job. There may be a wage freeze, and that's sort of relevant in today's experience of austerity measures and tightening belts and what have you. That's where we are. That's the answer to that one. Now, question 8 is really, really nice. Deserves its own page. It's given a grade A rating. The language is tricky. a radioactive substance, and it's called bismuth. But you never heard of it. Bismuth 210, and this thing decays. Obviously, then releases radioactive particles and radioactive rays. If it gives out gamma radiation, I don't know. So it decays at a rate of 12.9% per day, every day. Okay, so this thing releases radiation, and it decays at a rate of 12.9% per day. There is 1 kilogram of this stuff to begin with. In other words, 1,000 grams. How much bismuth 210 will there be after 2 weeks? Okay, I'm reducing down by 12.9%. If I take that away from 100, it's a dodgy figure. 100 minus 12.9, that gives me 87.1% left of its original mass, shall we say. So here I go. How much is left after 2 weeks? Well, 2 weeks is 14 days. So 2 weeks. This is what we've got. We've got a kilogram multiplied by 0.871 to the power of 14. Alright? So here I go. So 0.871 raised to the power of 14, and I've got a kilogram there. This is what I've got left. I've got 0.1446 kilograms. In other words, I'm down to 144.6 grams. So I'm nearly down to a tenth of my original mass of radioactive substance. It has been decaying for the last 2 weeks. Right, it then says, how many more days will it take for the bismuth 210 to decay to less than a tenth? In other words, I want to go below 0.1. Well, it's trying improvement, isn't it? So let's just write a little note here. That's 14 days. Let me try 15 days. So I'm going to go 1 times 0.871 to the power of 15. If it's power of 15, then it's 1 extra day. Let's just see where we go. 0.871 power of 15 equals, no good, 0.12597 kilograms. So let's try again. 1 times 0.871 power of 16. This is the 16th day. In other words, 2 extra days. So let's just do that. 0.871 powered up to 16 days. Getting there. Oh, look. 0.10972 kilograms. I'm not there yet. I've got to go below 0.1. 1 times 0.871 to the power of 17. So after 17 days, 0.871 times 1, of course, raised to the power of 17 gives me, I've got it, 0.09. That's almost 0.1. I've dropped below it, 556 kilograms. Therefore, 3 extra days. Done. Read the question. How many more days will it take for the bismuth 210 to decay to less than 1/10 of its original mass? Well, I've gone down to below a tenth on the 17th day, which is 3 extra days after the 14th day. And that's it. I think I'll do question 9. It's got a great big star thingy by it, and it's grade A, probably, because it's gone beyond the grade A section. So I really like this question, and then I'll stop, and that's enough of increasing and decreasing. The organisers of a sponsored swim give 40% of all the money raised to children's charity. So this is me setting up the question. So to children, they give 25% of the remaining money. Right. So I've got 60% left, and then they're going to give 25% of this money to whom? An animal sanctuary. Okay. Obviously you don't need to write all this in the exam. This is me setting up the question on the screen for you. And the rest to a local hospice. Well, if 25% of the 60% is going to the animals, the remaining 75% of that 60% is going to go to a local hospice. Right, I've got the question set up now. A. What percentage of all the money raised is given to the local hospice? Essentially 60%, 75% of the 60%. Remember, the 40 is going to a children's charity. So here I go. So for part A, this is it. It's 75% of the 60% of all the money. So 0.75 times 0.6 equals yet 0.45. In other words, 45% of all the money raised goes to the hospice. Right, the organisers aim to increase the amount raised by 20% each year. Okay, they want to increase it by 20% per year. The Treasurer says that it will take 5 years to double the amount raised. Do you agree? So I'll put here 5 years. Well, let's take a look. If I'm increasing by 20% a year, I'm adding 20% on top of my 100% I got the year before. So that's 120%. Now, after 5 years, I just multiply this to the power of 5. Now there's 1.2 times 1.2 and see what we get. So 1.2 raised to the power of 5 gives me, this is what I get, 2.488. Look, that's gone above 200%. It's gone above 200% because it's gone above 2.4. There it is. So therefore, that's not correct. So let's just try 4 years. So it's 1.20 raised to the power of 4. See what we get. Yeah, I've got it. Look, 2.0736. I've gone above double by 7.36%. So yeah, I've done it in 4 years. Let's just try 3, and then it's a bit like a trial improvement thing, really. So I think that's going to drop below anyway. But let's just show it. Raise to the power of 3. Yeah, that's no good. So it's 1.723. Well, this shows that 28. Well, this shows that after 3 years of an increase by 20% year on year, I've actually gone up by 72.8% on top of my original 100 3 years previously. So in order to double the money that's coming in, you've got to wait for 4 years. So I'll put here, therefore, 4 years, not 5 years. Is that alright? And that's me showing all my working. I'll stop there. That's probably the hardest question in the section, and that's 4.1 over for now.